Hello friends, welcome to Dharrsan Education. Now let us go on to our video. In this video, let us explore about Class 7 Science, Physical and Chemical Changes. Changes around us. Changes take place around us all the time. The changes can be divided into different classes depending upon the nature of the changes. Changes are of two types and they are physical change, chemical change. Physical change, a change in which a substance undergoes a change in its physical properties, is called a physical change. Properties such as shape, size, color, and state of a substance are called physical properties. A physical change involves the following changes. No new substance are formed. The properties of the substance remain same even if the physical state changes. Properties like appearance, texture, color, smell, etc. changes. Chemical properties of the substance do not change. Note here, it is chemical properties, not chemical change. Physical change is generally reversible and the things can be get back to their original form after the change. For example, water can be changed from liquid to gaseous state or to solid state, but there is no change in their chemical structure of ice, water and steam. Chemically, all the three states are same, but only physical state of the water changes. During a physical change, sometimes a change substance disappears but can be recovered after the change. For example, when sugar is dissolved in water, it disappears. If you taste the solution, the sugar is still present in the dissolved form. If water is evaporated, we get back the sugar. Chemical change, a change in which a new substance is formed, which have different properties than the original substance, is called as chemical change. Chemical change involves the following changes. Chemical change are irreversible. The original substance cannot be recovered in most of the cases. One or more new substance is formed. Heat or light or both may be produced. A gas can be formed. A change in color or smell may also take place. Some fruits and vegetables like apple, banana, brinjal and potatoes develop a brown layer when they are cut and kept in open. Certain compounds present in them react with oxygen present in the air and get oxidized as a result of chemical reaction. Activity to show an example of chemical change. Procedure. Take a small piece of magnesium ribbon and clean its tip with a sandpaper. Hold the ribbon with tongs and heat it on a burner. Magnesium ribbon burns completely. Collect the ash and dissolve it in water. Test the solution with blue and red litmus paper. Observation. When magnesium ribbon is burnt in air, it burns with a dazzling white flame. Dazzling is extremely bright. It forms a powdery ash when it is burnt completely. A new substance is formed after burning magnesium ribbon. This powdery ash is known as magnesium oxide. Reaction for this is magnesium Mg plus oxygen O2 gives rise to magnesium oxide MgO, and the balanced equation is 2Mg plus O2 gives rise to 2MgO. When magnesium oxide is dissolved in water, a new substance called magnesium hydroxide is formed. The equation is Magnesium oxide MgO plus water H2O gives rise to magnesium hydroxide MgOH taken twice. And balanced equation is MgO plus H2O gives rise to MgOH taken twice. When a drop of magnesium hydroxide solution is kept over litmus paper, red litmus turns into blue, which indicates it is basic in nature. Displacement reaction. Whenever a more reactive metal is added to a salt solution, the less reactive metal is displaced from a salt solution. When iron is dipped in copper sulfate solution, a displacement reaction takes place. Iron being more reactive than copper displaces copper from the copper sulfate solution. This copper can be deposited on the iron. This reaction is known as displacement reaction. Displacement reaction is an example of a chemical change or chemical reaction. Displacement reaction is used to deposit a thin layer of one metal on the other metal. Deposition of the metal is also done by passing current through the solution. Activity for displacement reaction. Dissolve some copper sulfate in a beaker with water and stir it with a glass rod. Add a few drops of dilute sulfuric acid to make a blue colored copper sulfate solution. Save a small amount of the solution in a test tube. Drop a nail into the remaining solution. Wait for half an hour. After half an hour, compare the color of the solution with the solution we saved in the test tube. Observation. On adding iron nail to copper sulfate solution, the color of the solution changes from blue to green color due to the formation of a new substance, iron sulfate. The color of the iron nail changes to reddish brown. Copper from the copper sulfate solution deposit on the iron nail, giving it a reddish brown color. Equation is copper sulfate solution, which is blue in color, plus iron gives rise to iron sulfate solution, which is green in color, plus copper. It's a brown deposit. Catalyst. A catalyst is a substance that can be added to reaction to increase the reaction rate without getting consumed in the process. Catalyst is typically speed up a reaction by reducing the activation energy or changing the reaction mechanism. Dilute H2SO4 or dilute sulfuric acid is the catalyst used in the previous activity. Ozone or O3. Ozone layer is present in the atmosphere and it acts as the natural shield against radiation. It protects us from harmful ultraviolet radiation which comes from the sun. Ozone absorbs the radiation and breaks down it into oxygen. Rusting of iron. Rust or iron oxide is formed by the reaction of iron with oxygen when iron objects are exposed to atmosphere. Rust is a reddish brown powder. The process of rusting can be represented by the following equation. Iron plus oxygen plus water gives rise to iron oxide or rust. For rusting, the presence of both oxygen and water or water vapor is essential. Rusting. Rusting is very harmful because the objects made with iron gets rusted and finally converted into powder. The most important methods to prevent rusting are painting, greasing, or oiling the surface of the iron objects by galvanization. Galvanization is the process of coating the surface of the iron with zinc or chromium to prevent rusting of the iron. Converting iron into stainless steel. Stainless steel is made by mixing iron with carbon and metals like chromium, nickel, and manganese. And stainless steel does not rust. Rusting occurs more in salt water. For example, the base of the ship. Crystallization. Crystallization is the process of separating pure crystals of a substance from its solution. This method is used to prepare pure crystals of many compounds like sugar, copper sulfate, alum. It is also used to prepare pure salt from seawater. A large crystal of alum can be prepared by adding a small crystal of alum in its saturated solution. Activity for crystallization. Take some water in a beaker and add a few drops of dilute sulfuric acid. Heat the solution. When it starts boiling, add some copper sulfate powder slowly while stirring continuously. Continue adding copper sulfate powder till a saturated solution is formed or no more copper sulfate can be dissolved. Filter the solution. Allow it to cool or undisturbed for some time. Look at the solution after some time. We can see the blue crystals of pure copper sulfate is formed. Thanks for watching. If you like this video, like and share and do not forget to subscribe my channel.